go ahead and jump right in. So as I said earlier, my name is Eng.Lois Kamga Ngameni, and I often go by Louis, so you can call me Louis. And I am part of the Colorado School of Mines that you can see here, the logo, and the ORI, which is Operations Research with Engineering, and also FAST, which is Fracturing, Acidizing, and Stimulations at the Colorado School of Mines. So here is an outline of my presentation. Please let me know if you can see this properly. If not, I might have to use a different type of screen or something. So the presentations outlined. First, I'll start with the objective. So what is this presentation going to be about? And as well as what are the takeaway I would like to go with at the end of these presentations. Then I'll move for the introduction of hydraulic fracturing, where I will talk about what is hydraulic fracturing, and a little bit of a history, and why do we care about hydraulic fracturing? What is it like? Why do we want to do hydraulic fracturing? Then I'll move for the boom in fracking and mentioning the shale revolutions. Then I will talk about the hydraulic fracturing in the US, what has been done in the US as far as hydraulic fracturing, and also the hydraulic fracturing around the world. And of course, I could not finish up without talking about the environmental issues, because I would like you all to be aware that there are some issues with hydraulic fracturing, and what are those issues, those environmental issues that we have with hydraulic fracturing. Then we will conclude with some discussions and some questions you might have. So as far as the takeaway, so today I would like for you guys to understand what is hydraulic fracturing and the technology advancement around it. What has been done, what is being done, and also what is, if a friend asks you tomorrow, what is hydraulic fracturing, you are able to tell him a little bit about it, what you know or what you understand by hydraulic fracturing. Then also why we started the process. So why are we doing hydraulic fracturing? And also what has it done for the industry globally, but also in the industry in North America, and as well as the controversies around hydraulic fracturing. So those are the main takeaway I would like for you to have today after these presentations, to understand those three concepts. And I hope to be able to achieve that. So now let's talk about a little bit of the introduction, which is the process of hydraulic fracturing, right? So hydraulic fracturing, it's pretty much propagating a fracture into the rock layer by injecting a pressurized fluid. I'll talk about this more than once because it's a little more complex than that, maybe not, but it's a little more than that. So I'll show some image to show how that is done properly. So the point is that we have to create a fracture, like the name says. It's hydraulic fracture, so we have to create a fractures, and we create that fracture by injecting a fluid under extremely high pressure into the rock. So hydraulic fracturing is a technique that is being used by companies in order to extract natural gas and oil that are trapped into shale thousands of feet underground. So it helps improve the production of oil and gas in unconventional reservoir. So why do we call it unconventional reservoir? Well, because it is not conventional, right? It's like when someone tells us something that is very different than what we used to, we say, okay, different, right? So it's not conventional. It's something that is not usually done. So that's really why we call it unconventional reservoir. So now, this is my formation right here, as you can see in here. So I have the ground. I have, the aquifer. The aquifer is actually a few feet below the formation, generally. Then about 7,000 to 8,000 feet all the way down deep, I have the shale formation. So the shale formation is where I'm trying to get at. It's where I want to extract my oil from. So that is the goal there. So in order to do that, that's when we use the hydraulic fracturing. But first, before we do the hydraulic fracturing, we build a well. So we construct a well. We're probably familiar with the vertical part of the well, but we don't only construct the vertical part of the well, but we also construct an horizontal part of the well. But the first step is to build this vertical part of the well and go down about 7,000 feet deep. And once we reach 7,000 feet deep, we do an inclination and we go underground here. And underground here at this level, we can go another 3, maybe to 4,000 feet deeper in length into the reservoir. And that's when we now started with the perforations. So perforations, it's including, once that well has been constructed, we throw in there an explosive. And an explosive at the end of it, what it's going to do is that it's going to create a fracture. So it's literally an explosive charge. And then it's like a detonation. Through detonations, we have that fracture that have been created. So that's what creates the first fracture. And that's how we perforate that well, and that's how we create that first fracture. So when that first fracture is being created, we then mix together water and sand chemicals, and we pump that through the ground, because then we have to create even more fracture and into the, so that's the high pressure pump fluid that is going to go under the ground there. So once that goes under the ground, we create even more fracture. So what it looks like, it's a little bit like this one. So the pressure builds until the rock fracture entirely. And then we have the water that is nearly 99% of what we've injected that flow inside, and they're creating cracks into weak spots, right? And then the sand allows the crack to remain opened. It's like propping a window. Like, you know, when you open a window, you can put a small, you know, depending on how you want to leave that window open, you can put a small rock right there, and then the door stays or the window stays open. So that's pretty much what we're doing. We use the pressure of our hand to open the door. Then once the door is open, we put a small rock in there to allow people maybe to come in and out as they please. And in this case, we use the pressure of the water to create a crack into the rock. And once that is done, we can now put in the sand to keep the crack open. So, and that there is done and repeated maybe 10 to 15 times every single time. So what we do is we perforate like we did earlier, then we created that here, then we create it again, and we create it again, and we create it again. So we're going to create a small set, about 10 small sets of fracture all across the formation, the shell formation. And that's what we do when we are doing hydraulic fracturing. Then, because of the amount of water we use for hydraulic fracturing, which I will talk about in a little bit later, about 95% of that water is taken back in, and it's recycled or reused for the next well we are going to try to fracture. So once that all that is done, we can now start the production. So now the oil is kind of flowing back up, and we start the productions. So I'm going to describe this process again, because a lot of things are happening into this process. And that's one of the key takeaway I want you to go with, which is that good understanding of hydraulic fracture, or the good understanding of fracture itself. So pretty much what we do is we drill the well, like you know, like we study in a regular drilling engineering class. We drill the well, then we can have some that are only vertical, but most of hydraulic fracture process, they are doing mostly a horizontal lateral, right? So they do mostly a horizontal lateral. Then we also do case and cement in area where we feel like there's too much pressure coming in, or maybe we have the waters in those areas. Then we perforate the casing with the guns, like you saw earlier. And when that is done, we pump the fracturing fluid, which is the high pressure fluid at, very, which is mostly 99% water, and then some chemical and sand, the other 1%. Then once that is done, we collect the water back up, and we start the production. And then when we talk about the casing and the cementing, why do we do that in the hydraulic fracturing process? It's pretty much for the same reason why we do casing and cementing in a regular conventional well, right? So when you learn into the drilling class, we put the casing, and which is the steel pipe for pressure. So we put the casing first, then we make sure that the pressure zones are all taken into consideration, are all fair. Then once that casing is set, we now cement to keep it in place, so that the hydrocarbon can flow back in. So it's pretty much the similar process, but because we have to do the perforations as well, and we have to do the casing sometimes in a horizontal manner. So that's where the differences lies into that casing. That could be sometimes horizontal, but we don't always get all the way that far in, well, because we can also have a vertical well that we've done hydraulic fracturing to it. But it's not economical, but it does happen as well. So as far as the perforations, how do we do? Well, the perforation is just using a perforation gun like we use again, with charge, right? And it goes through the casing and into the cement sometimes, or it can just go through the formations. When we have a horizontal well bore, it goes straight up to the formations. And then we use the explosive gun and we try to keep the door open. And then what is the fracturing fluid? So that's probably one of the biggest controversy because of the state regulations and the company regulation around the fracturing fluid they use, because it's some sort of secret formula and they don't want to share it with other companies because your fracturing fluid dictates how well you're going to have a good hydraulic fracturing job or not. So hydraulic fracturing is probably about 98% water and sand. And sand, I mean really sand. And we call it in the industry propant, which is coated sand, and it comes in different and various form. I will describe that sand in a little bit there. And the other 0.5 to 2% are the additive that enhance fracturing. And I will also talk about the additive there into a little bit. But another critical component I want to highlight is the 3 to 7 million gallons of fluid that I use on a typical horizontal well bore. That is very, very controversial, because most of the area where hydraulic fracturing are happening, we also have farming land, right? And we know farming use a lot of water as well. So it became a really a big problem there. So let's talk about the propant. So the propant is pretty much sand that is pumped downhole, and it keeps the fracture open. Like I took the example earlier of opening the door and keep a piece of rock there. But now, depending on the type of door you have or the type of opening you're trying to have, you can have a different type of rock you might want to use there, right? And similar with the sand. So there's 3 major type of sand: infiltrated sand. So sand that has not been done anything to it, just regular sand. It can be rounded or just, it's some sort of sphericity around it. Then you have resin coated sand. So it's been coated with the resin all around it to make it a little bit stronger. And we also have ceramic sand that is artificial. It was designed artificially. It's extremely expensive and it's very strong, and it can resist at high pressure. Imagine if instead of going 7,000 to 8,000 feet down, you probably go 10,000 to 15,000 feet down. You literally have double the amount of pressure you might, you might encounter down there. And you might want to use ceramic. It's extremely expensive compared to the infiltrated sand. But some companies need that and it's being used. So we pretty much select the sand based on the strength needed and the size of the sand you are going to need. Similar with your door. If you prop open your door, you are going to think about how strong is the door, or the door mechanism to lock it back. What type of rock do you want to use there? You want to use a smaller, a bigger one, or do you want someone to see that the door has been propped open, right? You might want to use a smaller rock to put there. So those are the decisions we make when we pick the propant that we are going to use. Then the chemical additive, like I said, it mainly depends on the well characteristic, whether you have a high salinity reservoir or low salinity, if you have a deep well or a shallow well. So they are some of the common additives we use are stabilizer, acid, gelling agents, biocide, and it's a mixture of that. And then again, I said earlier, this is very it's a secret formula for some companies, and they don't want to share it. They want to keep it for themselves, just for competition's sake. So again, the 3-step for hydraulic fracturing: pump the fluid, the formation is cracked, fracturing fluid to enter and extend the crack further in the formation. Then to keep the frac open, injection soap, and then we use the sand to keep it open. So you have the pump of the fracturing fluid, the formation is cracked, and we keep it open by putting some solid propane in there, and we can start it. So here it's a big picture of what is really happening on the fracturing fluid. So there is a lot of horsepower into the fracturing fluid, and you can see that with these machines. You have water tanker, you have the mixed sand that is being injected mixed with the water tanker, You have the recovered water that is being put back into a pit, and some are taken for treatment. You have the storage tank, you have the natural gas. So you probably have about 20 to 30 different trucks all running at the same time on the frac zone. And they're just running. Like I said, it is a lot of horsepower that is being used there. So you have your vertical that is turned into horizontal. Then you have your fissure that have been created. And that fissure being created, you put the sand in there to keep it open. And that's how you get your fluid back in. And right here, you have your well, meaning your casing and your cement that is done right here, just outside of it. And just like here as well. So that is how the hydraulic fracturing process is happening. And I think I've covered a lot of, or if not enough, of those different steps that are taken into considerations when we are going forward with the hydraulic fracturing process. Now, I want to let you into a little bit of history of the hydraulic fracturing process. So it started in the 30s, where acid was used to stimulate a well instead of explosive, right? And then the idea of pressurizing came through here. So 10 years later, or about 15 years later, Standard Oil at the time, which is now a mixture of, I think, ExxonMobil, introduced the concept of hydraulic fracturing, but it was not economical in the 1947. So it is something that has been around for nearly 70 to 80 years, or maybe more, because we knew it, we tried it, we did research on it, but it was never economical. And because it was not economical and because we had access to easy oil, so to speak, we went back to that until about 2000, when in 2010, we had about 2.5 million of hydraulic fracturing treatments around the world, not just in the US, but around the world. However, the US has taken a big stand into hydraulic fracturing in the last few years, and I will explain, I'll get into that in a little bit as well. So far, what have we done? So far, we learned about hydraulic fracturing. We talked about the process, meaning how what is needed for hydraulic fracturing, where it is done in a shale formation. We talked about how we perforate the wells, how we use the pressure to create a fracture and to keep them open. And we talk about the additive that is used, meaning the sand and the other chemical that are used for the hydraulic fracturing process, and a little bit about the history of hydraulic fracturing, how it started and where it started, with what company started and why it was not used then, and when it started being used. So I would like to know if anybody has any questions, because again, that's one of the major takeaway, and I really want you guys to understand that concept of hydraulic fracturing. So I want to see if you guys have any questions, then we can see, move into seeing where and why it is being done and the issues with hydraulic fracturing. So any question now, or you can wait until the end. It's really up to you. All right, so if there's no question, I'm going to keep on moving forward, and I will talk about the boom. So the boom of hydraulic fracturing, it's all started with America wanted to be energy independent, right? So a lot of the oil depended on Canada, Mexico, Arabia Saudi, and Iraq. And where in the Middle East, where there is a lot of uncertainty and geopolitics issues. And America wanted to stop depending for oil in that regions because of the instability of the regions. And they said, well, maybe it's time for us to invest enough money into the technology and to figure out how to get hydraulic fracturing at a cheaper price so that we don't have to depend on Middle Eastern country or countries where there is a lot of instability. And also it's a lot more greener, so to speak, than coal or oil, in case we're doing shale gas. Because when we do hydraulic fracturing, it's either for oil or for shale gas, for oil shale or shale oil or for shale gas. So it's a lot greener when we do it for shale gas. And I will also show that why America does not want to stop it, because of the need for gas. And then again, like I said earlier, the boom all started with geopolitical issues. So where do we get our energy from? as of like maybe 2-3 years ago. We still heavily depend on coal. About 20% of our energy still come from coal, and 36% come from natural gas. And over 26% come from natural gas, and over the and 36% from petroleum. And over the years, natural gas 26% has been increasing considerably. And I will show again in the most recent work that was done how natural gas has been increasing. So yes, in short, we mostly get our energy from petroleum and natural gas, both of whom can be hydraulically fractured. That can be obtained through hydraulic fracture process. So how do we use natural gas we get? So 34% goes into industrial and 31% into electricity. We know how electricity is important for human development, for development of nations, and also how industrial is important for that. We are in need of new industrial revolutions with COVID and the year 2020. All that has happened. So it's important to come up with that 34%. And so that come up to about 65%, plus the 19% from that goes into residential. So natural gas has a huge use into our everyday life, meaning industrial, commercial, residential, and electricity, and even transportations. So it is needed, and we need to find a way to get it best. So here I want to present to you a shale gas place in the lower 48. By lower 48, we mean into the 50 states in America, where are the shale gas plays, and shale and oil gas play pretty much. And you can see that there is a lot of it around, but the biggest one and the largest one is probably here, and you can see it is called the Marcellus. So the Marcellus is probably one of the largest plays around the US, concentration plays around the US. And to put it better, I have those major shale play here. In the back end, it's a big play, which is mostly oil. And you can find it in North Dakota, in Montana, and in Canada. Then you have Barnett, which is in Texas, and it's mostly natural gas. You have the Eagle Ford, which is oil and natural gas, and is found in South Texas. And you have the Haynesville, which is natural gas, and is found in Texas and Louisiana. The Marcellus, which is in Pennsylvania, Ohio, New York, and West Virginia, is also mostly natural gas. The Woodford in Oklahoma is oil and natural gas as well. As you can see, there's a lot of natural gas keep coming back into it. So there is a huge amount of natural gas that is being found and that need to be fractured. So that is why natural gas, again, I showed a slide earlier, how it is being used all around and why it is extremely important for us to have that. So now the revolution of fracking started with the creation of the economic surplus, right? So in 2010, when we started with the shale gas, it created the consumer a surplus of nearly $100 billion. So that is an incentive to put more money into the economy and to find a way to keep on creating that surplus. And obviously, it also increased the job market for Americans living in a very rural area. And you know, the oil field was really busy at the time, and anybody who would want to go down there was able to find a job right away. But it also helped with energy availability. Again, like mentioned earlier, because of geopolitics, America wanted to stop depending on the energy from nations that have a huge political instability. And they wanted to have more of energy availability right next to them. And that's how the Marcellus Shale, as I shown earlier, which has probably one of the largest reserve of gas into the US, 500 trillion cubic feet of gas. And that supply is estimated to last for the next 90 years to come. So I will show you what you can do with 1 trillion cubic feet. And they have 500 trillion cubic feet of that. And also a smaller carbon footprint, right? When you compare that to coal, you know, you have an extremely smaller footprint of carbon, right? So, which is also another good thing there. So now let's look at the Marcellus Shale, the map itself. So this is a map of the Marcellus Shales. It covers West Virginia. You can see the name here. It covers Pennsylvania. and some area of up New York, upstate New York. So it is big, it is huge, and it has most of the natural gas reserve in the US. And it produces a huge amount of natural gas every year. So that's 20 trillion cubic feet of natural gas that's been produced every single year. And with 1 trillion cubic feet, you can have electricity and heating for 15 million homes. So, and it produces 20 million cubic feet of that. So I just wanted you to put things in perspective and see what you can do with 1 trillion cubic feet. 15 million homes can be powered on. You have 20 trillion of that, and you have the potential to produce more 500 trillion cubic feet of that. And with that, you can also fuel 12 million natural gas vehicles for 1 year. So there is a big, huge of the natural gas production, the use of natural gas as a whole. So that's why it is so important to for America to keep on doing hydraulic fracturing to find ways to have the natural gas being available for them. So let's look at the fracturing, the history of fracturing into the US. From 2008 till about 2017. Into the light blue or the lighter color of both, it is natural gas. And then into the darker color is oil. So as you can see, Russia was on the top of the US when it comes down to oil and gas productions, oil and then even natural gas productions. And obviously, Saudi Arabia was on the top only for the oil productions, as they've been always known for the oil production over the years, but very little for the natural gas productions. But if you look at what happened from 2010 until about 2012. In 2012, we have the US who was first producer, second producer, right passing Russia, and still right behind Saudi Arabia in 2012 when it comes down to oil. But it was the top producer when it comes down to natural gas by 2012. And by 2013, it passed Russia and Saudi Arabia into the productions of oil and natural gas. So that was an amazing breakthrough here for the US. And he had planned that in 2020, it would become now as well an importer, not just a producer and then the user, but it will also export that natural gas that's been produced. And look at what has been done in 2017 and into the year ahead. It has literally passed both countries, Saudi Arabia and Russia, into their production of oil as well as natural gas. And that was an amazing time there for the US to claim that energy independence. And now, how is that being used now? Like, where has it been used? How much of it is being used where? So it's mainly been used, a natural gas part of that production, in order to generate electricity. Electricity to use in industrial home, in industry, for industrial use, and also electricity that could be used for not just for industrial use, but also for renewable. Sorry, not for industrial, but also for home. So, and you can see that here that 37% of natural gas has been needed so far up, and it's said that it will still increase to during the year 2030, and it will find its way to decrease around 2050, where renewable will take the lead to 38%, while natural gas will still be at 36%, which is still considerably high. And that's the reason why they think it's very important for them to keep on fracking for natural gas. And here I have a slide showing the how important it is, but also how they see the importance for the tight shale gas. And you can see again here how tight and shale gas is going to create a huge importance over the years compared to other sources of energy. So they reach about 91% of domestic natural gas productions in 2050 to be said. And while in crude oil would reach about 73% of oil production by 2050. So again, there is a big demand for both of them, and they would increase substantially over the years. And I think we've reached some sort of peak, sometimes around 2025, 2020, 2030. So that's one thing we see there as well. So while in fact the nuclear will decrease over the years up to about 12 to 13%, even less, some people have said it. And while the solar and then the wind will also increase a little bit, but still one of the biggest increase we've seen, the biggest need we've seen, not for oil, but also for natural gas, because of the electricity component that we have towards it. So that's why also even the US think that by that time they have becoming an exporter of petroleum and natural gas starting 2020, and they will keep on exporting to help other nations as well. And while in fact, in the year 2000, they were a huge importers until about 2012, when you've seen there's a plateau there because they started reaching pinnacle in productions, and then they still imported because of the recessions and things that happened in between 2014. But then again, they will be an exporter by 2020, meaning this year and later on. So it is extremely important to have that. It is extremely important, the process of hydraulic fracturing, as well as fetching for natural gas, mostly, more than oil. And that is why other nations around the world have taken a stance in to find out how they can get natural gas through hydraulic fracturing. And I will talk about some of those countries around the world. So we have Australia with the Vitalo basins, and Australia has been really pushing for hydraulic fracturing. And Canada has been doing that, although 4 of their provinces have refused to push for hydraulic fracturing. And those are New Brunswick, Newfoundland, Nova Scotia, and the province of Quebec. In China, because of their populations, I don't think China will ever give up on the need for electricity and for natural gas, therefore. And in 2011, they started heavily drinking and bringing in scientists, even from the US, to help them understand the process and concept of hydraulic fracturing and how can that be applied. Similar thing with Denmark. And Germany actually started with the research in 1975 because they wanted to find out how beneficial it could be for the economy, how beneficial it could be for them, and whether or not it was a good thing to move forward toward that directions. Similar with Netherlands, their neighbor, but much more later in 2007, they realized the need for that and how they can make things happen there. We have also New Zealand, Poland, and Romania, and even South Africa. I think it's the only African country, sub-Saharan African country, that has pushed towards hydraulic fracturing and fracking for natural gas. We also have lately a country that is not there, Saudi Arabia, and also the Emirates, because they've used oil to provide electricity into the country. And they decided that it was better to find a way to do hydraulic fracturing, was more economical, and then to frack for natural gas and to be able to to use natural gas in order to provide electricity for the country. So conventional versus unconventional, what is the difference there? Yes, I know the technology is one of the difference, but you also have to keep in mind the cost. The cost of unconventional can be for the operational issues without counting all the health issues that came around it, and also the controversies that have been around the unconventional compared to conventional. But also, most of the conventional can be found in places with huge political instability, and then the geopolitics made the world or Americans to look at more, it took an in-depth look into unconventional reservoir and figured out a way to get that out of the ground. And obviously, you also have other sources of energies, like electric cars that could be taken into consideration, but still need a huge natural gas consumption of energy there, which is still requires some sort of hydraulic fracturing. So let's talk a little bit about environmental issue. So we've talked about so far the process and the concept of hydraulic fracturing. We talked about where it is done within the US, the different place, the most important regions within the US where that is done. And we also took a look at around the world where it is done. But now let's, and also what it has done for the economy of the US mainly. Let's focus a little bit on the environmental issues here. So issues with fracking. So one of the main issues with fracking has been the water consumptions. Like I said earlier, it consumes a lot of water. And water is becoming heavily a scarcity around the world. And hydraulic fracturing is used a lot of water. And imagine you are in a farming community where you actually provide food for the people around that community. They will see the food they eat as more important as the energy. Although the energy might be more important, or maybe they're both equally important, but because the food they eat is something they can directly consume and see a benefit for it. While energy, they might have to turn on the TV, watch the TV, then put into the gas, then drive around. So yes, they see the benefit for it, but then it is not that something as satisfying as having eating right now, right there. So as far as water consumptions, the master display that I showed earlier consume about 20,000 million gallons of water as a whole for all the wells in the master display, right? And think about 1.5 million people use about 38,000. So that's nearly, it's double, yes, but it just to show you how much water is being used for hydraulic fracturing. So that's one of the environmental issues there. And if you want to look at another perspective, if you like golf, have you been to the golf course? Yes, 3.8 million gallons of water per well, but it's also about 4.4 on the golf course per week. So it says that we use a lot of water for hydraulic fracturing, but we have also other things like watering a golf course that has been using a lot of water, right? So there's a controversy there, but then again, it's like in for penny, out for pound type of scenario. We blaming, and agriculture also use a lot of water, but then again, it's just that hydraulic fracturing is already so much controversial that we felt like it's a problem. We also talk about the water contaminations, right? Because pumping chemical near the water table and the failure in pit and liner could leak the chemicals in. So because I saw earlier that the frac fluid is composed of chemicals, that a formula of chemicals that most people don't want to talk about because they think it's a secret, or they see it as a secret because that's what make their company do better hydraulic fracturing process. And also the other one is an earthquake, right? So earthquake, it's been a big problem for that, and also social disruptions and community health because of the noise and the emissions that come from the truck. So some of the mitigations for that have been the Green Frac project. So that was launched by Chesapeake Energy in 2009, which was a research initiative where they were trying to find out what informations are used, like what kind of additive, chemical additive are used, and if we really need them in the field, and how do they affect our health, and what can we do not to make it happen. So that's one thing that they've done to mitigate the issues we had here with the water contamination and pumping of the chemicals. So the next thing was to look at refracturing wells, right? And refracturing wells meaning that instead of drilling new wells and getting a larger footprint, so instead of drilling new wells, we can go back to the wells that have been drilled and reduce the surface area of the wells used and work on those past wells by using a refracturing process. So let's just refracture it as much as possible. Then we can reduce the footprint we'll be using, and hopefully it will create less issues. We also have talked about closed loop fracturing. So meaning that we are going to use a system where the water that has been used could be reused and reused. So we put the water in only once, and we can circulate the waters and allow for reuse of that water into the wells and different wells around it. So that will save again a lot of water use here, and then the people could use water for other things like watering the golf course or for agriculture. And also pad drilling, right? So pad drilling is the fact of drilling multiple wells at the same site. And then again, this is another technique that was used to reduce the acreage and also the truck that have been used. Like I said earlier, sometimes in a hydraulic fracturing site, you probably have around 50 trucks that are waiting, and those 50 trucks will be used or are going to get used in order for different components of hydraulic fracturing. So one thing that's been done there is that we can reduce that acreage and the truck use, and also that will also help with reducing of the emissions and also the traffic of the truck. Because some of the communities have said that, oh my gosh, there's so much traffic of the truck, and that creates more emissions, and kids, can cross the street when the trucks are driving by. So it's just a danger to the community. And that's also similar to centralized fracking or centralized fracturing, where we have multiple wells from a central part. And that's also another reduction of that. So yes, I know that I've talked about hydraulic fracturing. I am a fracker, as they like to call us. People who are doing hydraulic fracturing, they call them the fracker. It's a fracker, and they frack the rock, and then they think we want to destroy the earth. But the truth is, as petroleum engineers, we would not want to destroy the earth, because earth is giving us oil, right? So if you destroy that, earth will not give us any more oil. So it would be wise of us, petroleum engineers, to preserve earth and to be able to keep our job and to have more jobs, right? So that's one thing as well. So yes, and I've also talked about some of the issues with hydraulic fracturing as a whole, and how we have found ways to mitigate that. So yes, there have been some controversies such as earthquake, there have been some controversies such as traffic emissions, CO2 emission. There's a lot of controversies about fracking, and a lot of people that will tell you that it is really bad because of the water scarcity and how much water we've used. So where do I stand with hydraulic fracturing? Because at the end of the day, I feel like it is a fight between economy and versus environment, right? And just like today, we have a fight between economy versus health, right? We have the coronavirus out there, and the coronavirus is taking a toll on all of us. It could be an economic toll. We cannot go to work, or we couldn't go to work for a while. Countries are worried and scared about the economy, right? So it is a big issue, but we also have a health issue there. So how are we mitigating that? So if we take a look at today's world, to what we're living in today, and I think it is a very similar question we have to ask ourselves, economy versus environment, with hydraulic fracturing. So I think the best answer for people today, economy versus health, has been to be responsible, right? You have to get tested to see if you have COVID. If you feel some symptom, stay home, don't go out. If you have if you feel like you don't need to go to work from home. If you go into the street, wear your mask, stay away from people, have 6 feet distance. So I think it's a similar thing we should do when we ask our question of economy versus environment. When it comes to hydraulic fracturing, we should say, okay, is it really bad? Should we use less water? How can we find a way to use less water? Can we do a research into the additive and the technology that's been used, the chemical that have been used? How bad is it, right? So I think that as scientists, we should certainly work on not only to better technology and science, but as an aim to have a better way of life. We will not use less energy. Like I know people say, oh, try to bike everywhere you go. No. Energy has taken us over to into the industrial revolutions. And I think it's going to take us again into a different era that we have right now with coronavirus, a new revolutions, and we will only use more and more energy. We just have to find a way to be more responsible about it. It's like saying that economy versus health, or we will no longer get to say hi to each other. No, we will say hi to each other, we will shake each other's hand at some point, but we just have to find a way to do it in a safely, in a proper manner. So we have to use, again, all the tools God has given us and to make the most out of it. So that's why I stand when it comes down to hydraulic fracturing and also economy versus environment, because that is a fundamental question of hydraulic fracturing. So with that, I'll conclude. I'll say thank you all, and then I'll be ready if you came up with any questions or if you have any other questions that you may want to ask. Thank you.
Thank you, Luis, for the wonderful presentation. If any one of you has any questions for our speaker today, feel free to ask. Always feel free to ask before we conclude.
I think I just got a question, and then it's the question has been to find out what current measures in the industry is taking to avoid the negative effects on both waste fluid disposal and hydraulic fracture chemical that cause degradation of surface and groundwater quality. So if I understand the question properly, you want to know that how do we mitigate those waste fluid disposal and also the hydraulic fracturing chemical that cause the degradation of the surface. So for the fluid, I think what has been done for the fluid is that we try to find ways to reuse the produced fluid. So the fluid that comes up within hydraulic fracturing, that fluid that comes up, it has been, how do you say that? It's called produced fluid, right? So it comes up and with oil as a whole, and then we find a way to, some people have found a way to collect that back into the tank so that we can reuse it. And other people have found a way to clean it, right? So through process of what we call reverse or forward osmosis, right? So it has been find a way to clean that as a whole, and to be used for other means and other purposes, and as well as chemicals. The Chesapeake Energy started the initiative in 2009 to study in depth every single chemical that has been used, right? So what are those chemicals and how bad or how good are they for the environment, and do we really need them? So I think that's what has been done for the waste fluid and the hydraulic fracturing chemicals. And that's the work that keeps on being doing to try to find a way to reduce the amount of water that's been used through reusing them. So we reuse the water, and also we can find a way to clean it. And once we clean that water, we can find a way to use it for other purpose. We can give it back to agriculture. So that's the two ways we found. So the other question that I had is, does fracking cause formation damage? Those fracking cause formation damage due to high pressure and an additive use. So yes, fracking definitely causes formation damage. Fracking causes formation damage because of the amount of pressure we are using. But does it cause earthquake is still the question. And in order to mitigate that formation damage that has been caused with fracking, we found a way to, again, use the casing and cementing, right? So that is one thing that we've done as a whole to mitigate that formation damage that has been caused. I hope that I answered the questions. And another question about the presentations, yes, that will be shared, and I will send it over to your SPE president, and hopefully we could share that with you guys. Why there has not been a big appetite for hydraulic fracturing in Africa, with only South Africa doing it? I think South Africa is doing it, but also North Africa has been doing that. I think Egypt or Algeria have done some sort of hydraulic fracturing, and mostly because they're after the gas, right? So the gas that has been used there, and the gas has been used, and they are okay with it, and they are okay to find ways to clean it and to put it away. So I think other countries in Africa have not really looked at hydraulic fracturing. Is mostly because they are happy with the conventional resources they are looking at right now. So they are happy with using the gas that they have acquired without having to do fracking. Because again, fracking is expensive. And if you don't have the technology already, it's even more expensive. So I think it's a cost issue for one, and also what we already have. We are really not in a position, some countries are really not in a position to say that, oh, you know, I have too much oil, but I just want to do fracking for fun, right? So it's not going to happen. So a country like Nigeria, they are not going to look at fracking because of the amount of oil they are producing. Similar with Angola. You know, South Africa is producing a lot of less oil, and they have huge resources of natural gas. So they're going to be very concerned about that natural gas they are having there and how they can be using it for electricity. And also, you know, Africa is very, you know, slow on the change, right? So those other issues have been there as well. So The other question that I had was, is it possible to use different ways to fracture on the same well? Yes, we can do, that's what we call refracturing. But so that's one of the mitigation I said earlier, that instead of fracking different area, like going into different area and keep on fracking and increase our footprint, we can do the same fracking into multiple wells. There we use different polymers as chemicals and water as well, and we can just refract the similar well. So that's one way that we've done that. And also earthquakes, the question is, what are the measures taken to reduce earthquake caused by hydraulic fracking? There has not been a strong correlation between hydraulic fracturing and earthquake. So yes, we sense some things at the surface, depending on the power we've used downhole, how much power, horsepower has been used downhole. We sense that at the surface, but we don't know for sure that has caused any strong earthquake. So that's still a strong debate there. People have said that it has caused earthquake, and everyone and other people have said that it has not. So it's still very controversial, and so that's one thing that we need to take into consideration. There hasn't been any strong correlation between the two. And also in conventional reservoir, can fracking be used to enhance the recovery factor? In conventional reservoir, because if you look at the difference between both, right? We do fracking in unconventional reservoir because the formations or the rock is so tight that we are not able to get the fluid to flow. So in order to get the fluid to flow back to the surface, we frack the rock by using high pressure, by using perforations and high pressure. We keep the rock open and we get the fluid to flow. In conventional reservoir, the rock is not so tight that we need to frack it. So we can just produce directly. Now, if we need to enhance the recovery factor, yes, some people have said that do fracking, but then you can go to produce so much faster that you might not need that fast production because you're going to make the rock bigger, right? You make the rock bigger, you get more oil. It's like you're opening your water or your tap water, right? If you open just a little bit of it to fill your cup of water, you're okay because it's going to fill that cup of water. If you open it too fast, it's still going to fill that cup of water. It's going to keep filling so fast, but then think about it. Do you need that cup of water to fill up so fast? I don't think so. So open that water tap just a little bit will do the job. And that's what has happened with a conventional reservoir. You have enough there to get the job in done. And to use hydraulic fracturing, that is very costly to enhance the recovery factor, while you could use other technique like, during the completion technique, like recompletions, going to a different zones and do different things. I think it's going to be not a very good use of power that we have, or that into hydraulic fracturing, and also not a very cost effective. So I think those are all the questions that I have so far. Unless someone else had other questions, please let me know. And if I was not very clear on any of the questions, please let me know so I can try to clarify that questions again.